Gene mapping is the process by which we determine what the position is of the genes along any given chromosome. Now, part of gene mapping involves determining what the order is of the genes along the chromosome. But to determine what the order of the genes is, we have to know what the percent of recombination is between each pair of gene along that chromosome. So, to demonstrate how we can use the percent recombination between each gene pair to calculate or to determine what the gene order is, let's take a look at the following example. So, let's suppose on a given chromosome we have three different genes. Gene A given in red, gene B given in purple, and gene C given in blue. Now, all these three genes are linked with respect to one another, and that simply means they are located on the same chromosome. So let's begin with part A. So let's suppose in part A we know that the percent recombination between gene A and B is 5%. The percent recombination between B and C is 3%, and that between A and C is 8%. So knowing what the percent recombination is between each gene pair, let's now determine what the order of the genes is. So let's suppose we have a chromosome. So let's suppose the chromosome is this chromosome right over here. Okay? So the question is, if we know what the percent recombination is, how can we use that information to actually determine what the order of the genes is? Well, let's begin with a reference gene. So we can begin with any one of these genes. Let's suppose we begin with gene A. Let's suppose gene A is found right over here. So because gene A is given in red, I'm going to designate it with the color red. So this is gene A. Now let's move on to gene B. Now we know that the percent recombination between gene A and gene B is 5%. Now recall in our discussion of gene mapping, we said that one map unit or one recombination unit is equal to 1% recombination. And what that means is, because we have a 5% recombination between A and B, the distance between A and B is equal to 5 map units or 5 recombination units. Now, we can place the gene B either above or below. Because that doesn't really matter, let's put it below. So let's suppose that gene B is found 5 map units below. And so this is gene B right over here, given to us in purple. So this is gene B. And the distance between this point right over here, let's say the center of gene A, and the center of gene B is given to us to be 5 map units. Okay? And the reason we know it's 5 map units is because 1% recombination, so remember 1% recombination is equal to 1 map unit. And because we have 5% recombination, that is equal to 5 map units. Now let's move on to the second pair, so B and C. Now the percent recombination between B and C is 3%, so that means the distance between B and C is 3 map units. Now we can either place C 3 units above B, or we can place it 3 units below C. So the question is, should we place it above or should we place it below C? Now, to answer that question, we actually have to look at the recombination percent, or the percent recombination between the final pair A and C. So the percent recombination between A and C must be 8%. And notice if we place C above B, so 3 units above B, that means it's going to lie somewhere here. And so because this total distance is 5 map units, placing it above B means the distance between A and C would be only 2 map units because 5 minus 3 is 2. And so what that implies is C, the gene C, must be placed below B. And that will work out because as we place it right over here, so this is our gene C, we know that the distance is 3%, so 3 map units, and that means this distance right over here is 3 map units. And the final piece of information tells us that A and C, between A and C is 8%, so that's 8 map units. And this works out because 5 map units plus 3 map units gives us 8 map units, which is equivalent to 8% recombination. So this is the gene order in this particular case, in case A. Now let's move on to case B. Now let's suppose that the percent recombination between A and B is still 5%, between B and C is 3%, and now the percent recombination between A and C is not 8% but 2%. The question is, how exactly will the order of the genes actually change? So let's redraw our chromosome. So this is our chromosome. So now we begin with gene A. So let's suppose gene A is up here, just like in this case. This is gene A. Gene B, so this doesn't change, it's 5%, so we're going to place B in the same location as in that particular case. So this is our gene B. Here's gene B. So this is still 5%, so it's still 5 map units. So it's 5 map units. But now we know that the percent recombination between A and C is 2%, not 8%. So the question is, where do we place the final gene C? If we place the gene here, 3 units below B, we're going to get the same arrangement as in this case, and that doesn't work because the distance between A and C is 8 map units, but we want it to be 2 map units. So the only other location we can place C with respect to B is above B. So if we place gene C 3 units above B, that's going to be somewhere right over here. So this is our gene C. And that works out mathematically because the distance between B and C is 3 map units. And that's exactly what we want. And the distance between A and C, well, if this is 5 and this is 3, that means the remaining is 2 map units, right? Because 5 minus 3 is equal to 2. And that is exactly what we are given. We are told that the percent recombination between A and C is 2%, and 2% recombination is equivalent to 2 map units. So of course, these are very simple cases. The more genes we are dealing with, the more complicated this process is. If we increase the gene number to 4, to 5, to 6, it becomes much more complicated. And in each particular case, to determine what the order of the genes are, we have to know the percent recombination between each pair of genes. So this is how you basically calculate the gene order during the process of gene mapping.